All right, welcome back, everybody. This is William M. Briggs, continuing our class of uncertainty and probability theory, the logic of science. We're on episode 19, and we're continuing on our lectures of what probability is not. Probability is not subjective. Probability is absolutely not subjective. I'm going to prove that to you today. It's sort of a consensus in Bayesian statistics that probability is subjective. I don't think it's true, and I'm going to show you why. It's important for all kinds of reasons, as we'll see. Okay, well, it's always important to get it right. That's our overarching goal in all of this class, is to seek the truth. And truth is not subjective. Truth is as objective as you're going to get. Logic is not subjective, and probability is just the completion of logic. So probability cannot be logic. So let's look at a problem. I'm going to follow my chapter 5 point something or other in the book. I'll have the lecture up in the notes, which you'll find below here, and you can read along in the book. So far, I've given you everything in the book, so I haven't skipped anything. You've got the entire book Uncertainty, at least up to the point at which we're at in the lectures. So you can go and read those. Okay, so let's suppose we have a problem. A probability problem. X plus y equals 7 is our first premise. Y equals minus 3 is our second premise. And I want to know the probability of x equaling 32. This is a negative sign. Why not? I can do this. So the probability, and I guess I give it a little subjective sub. I will say the probability that x equals 32 is, I don't know, 90%. If probability is subjective, I can do this. Would I do this? No, but I could. If you insisted, one second, there's a nasty wasp that just flew in here. Whew. Tough little bugger. I have the doors and windows open. It's kind of a warm day, so the thing got in. Anyway, he won't be joining us anymore, subjectively or objectively. Okay, but if you, as a teacher, were insisting that probability is subjective, and the student said, well, I think it's 90%. All demonstrations of logic are out the window. You have said probability is subjective, so he could do this. Of course, math is different. So you think math is different, but math is not different. Math is just logic. We're just going through all this stuff logically, and I agree that this is the wrong answer, but I agree that probability is not as subjective. This won't convince you, of course, this one simple example, so I'm going to give you many others. Remember, all probability fits the schema. The probability of some proposition of interest, given some premises, data, observations, model, whatever you got. Something that you assume is true. This is subjective. This is subjective. The proposition of interest is anything you pick subjectively, just like in any logic thing you're trying to solve. This is subjective. This evidence that you're assuming is subjective. But this creature right here is objective. Once you pick these premises, once you pick the proposition of interest, then there's no more choice. The thing becomes objective. So I say, once you've picked these premises here, and I have picked this proposition of interest, the probability of this being true becomes rigorously objective. No more rigor than we can get than this. However, probability can seem to be subjective, as I'm going to demonstrate to you, because both of these pieces are. And it's forgotten that this piece can't be subjective, but these are, and so people get confused a little bit. So I have some more examples along those lines in the book. I'm not going to do that. I'm going to give you instead, maybe I'll come back to it as a home. I'll leave it as a homework problem. I'll put it up on in the link below, in the description below, and in the written lecture on the webpage and so forth. I'll have the homework problem of one of the things I skipped. The answer is going to be right there for you. So don't cheat and look ahead, because you're only, as teachers are fond of saying, cheating yourself. Okay. Suppose our evidence is a heck of a lot of people like this product. I'll just call it P. And I'll add to this premise, Mary is a person. So what's the probability that Mary, M-A-R-Y, I can't spell Mary likes, given E? A heck of a lot of people. What does a heck of a lot of people mean? I don't know. So the best I can say is hi. I'm going to call that semi-rigorous because, and there goes a piece of chalk into the great beyond. Probably joining the wasp in the grave. I don't know. So, I could say this if I like. There's no new number I could come to. But other people will say, well, you know what? Heck means 8 out of 10. And for them, then the probability is going to be 8 out of 10. Other people will add other sorts of premises in here. I don't know. A heck to me means they're going to add premises to, this is plus E. They still keep the premises E, but they add that heck means 8 out of 10, or they mean some other number, or they do something else, but they're adding premises. They're adding premises. They're adding to this right-hand side. And if you change the right-hand side, if you change the evidence, what's our number one lesson in this entire class? Why, you change the probability. If you change this evidence, you change the probability, as long as it's probative of the proposition of interest. So that's what it is. And so, but people do this, they don't write it down. And so this is, we met, if you followed the two envelopes problem, that was a problem that I gave, I think 2 weeks ago, by the time you're seeing this, as a kind of a extra class, not part of the actual class, but just sort of fun. Notation killed us and created a paradox where there was none. Purely because of notation, bad notation, being slavish to the notation. Here it's a case where notation's killing us because we're not putting it in. If we just say probability is something, a lot of people can disagree about what a heck means. Of course they can. And their disagreement comes in different numbers for this. And their desire for having a number. Why should they have a number? You don't have to have a number in probability. A heck is not a number. You can convert it to a number by adding whatever premises you like, but that's a different problem. Okay, so probability again seems to be subjective because of maneuvers like this, and people don't write it down. They'll just be writing things like probability Mary likes. That's all. They won't put the condition. They won't put the conditions in there. The up and down bar here, and plus all they just won't list them. There'll be a lot of words and text and so forth, but it's forgotten exactly what we're conditioning on. And that's what led to that paradox too. If you forget what you're conditioning on, you can come up with any number, any kind of a paradox. Okay, let's do another example, a very common one. I'm going to get rid of this up here. Sports, of course, are exceedingly popular, or they used to be anyway. I mean, it's become so greedy and corporatized and everything else nowadays. They've sucked the fun out of a lot of it. So, but that's neither here nor there. People still enjoy a lot of sports. So let's think about, so today it happens to be that, I'm from Detroit and I grew up playing baseball, liking baseball. So let's look at the Tigers win. They're playing today. On the day I record this, what's the probability the Tigers win today? Well, here I've made the mistake already. I've not written the notation down. I've not written my conditioning information down. But so you'll have a lot of disagreement. Some people will say 10%. Others will say 50-50. And some others might say 90% or whatever. There'll be a whole range of things you're doing. And the reason is, if I can add to this notation here, one guy will focus on, say, the pitching. Another guy will focus on the batters who are going to be healthy and playing. Another guy will focus on the past record. all of it, perhaps, or another guy will do the last 10 games, or whatever. Still, a statistician will come along and he'll use a rolling model of however many games, X games, and so forth, with a bunch of premises that go into the model itself. We haven't even done real formal models and so forth. And this will come up to a whole range of different probabilities, all because they are picking different information to condition on, which all give different probabilities. There is no probability. There is absolutely no probability the Tigers win. That's also from day one. It doesn't exist. There's no probability the Tigers win at all. There's no probability you have cancer. There's no probability the sun will rise in the east tomorrow. None of that, nothing has a probability. I cannot stress that more strongly. Things only have probabilities with respect to evidence that you assume. You change the evidence, you change the probability. The probability the sun rises in the east, we'll call that SE. Given the sun rises in the west is 0. That's just a fact. That's a fact of logic. It's not true that the sun rises in the west, but that has no bearing whatsoever on this rigorous probability. Okay? I mean, I could have math problems that I say stand for real things, and you'd have no problem believing me. But for some reason, when it comes to probability, people rebel about this. Because in a good way, they're trying to think of the causes of things and the nature of things. And that's a very good way to start thinking about things. But that's not what probability is. We bring cause to probability. Probability doesn't give you cause. That's going to be a lesson I'm also going to hammer home. Okay. Here we go. So here's why how some mathematicians might quail at all this, and they'll say, well, oh no, I think I could give you an objective probability or a subjective probability out of this using fancy techniques. And even Jaynes kind of makes this mistake from time to time. So here's our premise: x plus y equals, say, 3. And I want to solve for x. What's the probability x equals something? Well, I want to have a probability x equals 1 or 2 or 3 or any other number I might want to put in here, given that x plus y equals 3. Some people say, okay, I think I'd look at this and I'd say I can't solve it. There's not enough information here to solve. I mean, you might write down that x equals 3 minus y. You can certainly do that. However, that doesn't tell you what number. It doesn't get you any closer to x equals 1 or x equals 2 or x equals 3, any number you want to stick in there. So people will say, aha, you know what we need to do? We need to stick a uniform prior on here, or maximum entropy. I'm going to assume that x, I'm going to draw a picture here. Here's a probability distribution. We haven't really talked about probability distributions here, but here's the probability, or something like the probability on this axis, and here are all the different values of x. I'm just going to draw a straight line, meaning it's possible x can be any number on the real line, all the way out from negative infinity to infinity. Well, that doesn't work, although people have invented all kind of mathematical manipulations to squeeze it in and work. However, this is not part of the problem. This is adding to the premises up here. And I can add to this, I can add this uniform business, improper priors. They call them improper priors. Improper meaning it's not a probability. I know it's not a probability, but I'm going to use it anyway because I want to get a mathematical solution. So I'm going to cheat and hope it doesn't bite me in the ass. That's what people do. I could use maximum entropy. We're going to get more into maximum entropy and so forth. I can add all kind of crap on this right-hand side I want. But each of these changes the problem. Each of these will give me an answer. And I can subjectively state what I think it is. Or I could just subjectively state, I know Briggs and he likes the number 7 a lot. I don't know why, but he likes 7. He just used it in the last example, so 7 Briggs likes. And then so your subjective probability of x equals 7 is high. Some number, 80%, 85%, whatever you like. All of this stuff is manipulating the right-hand side. And you could always come up with an answer, if you put stuff in on the right-hand side. There's no argument about that. All of this is allowable because it's subjective. But the answer itself, this probability, the entire thing is just conditioned on what you say here. You could subjectively stick in things here, but if I tell you, you can't subjectively stick in things where they don't belong. So, you know, if I have an urn that there's 10 black and 5 red, and I want to pull out a red, so the probability of red in that urn, red, in the urn where there's 10 red or 10 white, I already forgot what colors I just said, 10 white and 5 red, that probability is going to be 5/15. You can't change it. A gambler will say, after watching somebody play this game, we're going to use, remember, we're going to take one out and put one back. We're going to do this with replacement. A gambler, after seeing red come up too many times, will say, red's been overplayed. It's overdue, man. It's gone. It's out of there. White is due. And he will subjectively increase his probability of white. Now, we know that's a fallacy when gamblers do it. It's just as much of a fallacy when scientists do it in aid of trying to come up with a numerical answer. They've committed a fallacy in an attempt to get an answer and to solve a problem. Sometimes that could be a good thing if we're trying to really get a problem, solve a problem where we don't know the answer or something like this. But sometimes it could just really fail and really bite. So for instance, suppose the guy who set this problem came up and he was interrupted, didn't finish writing all his premises and everything, and you went to this whole maximum entropy improper priors sequence of improper priors converging to a proper blah, 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 all this math we can get to later. And the guy says, oh, yeah, sorry, X turns out to be, I don't know, I just wrote this down, 7 plus 3i. Okay, there we go. Aha, 7 plus, oh, we didn't even think that these could be complex numbers. No, we didn't think. It just depends on what you're going to stick there. So this turns out to be real important in physics. I mean, it's not so much in like sociological models and so forth, but complex numbers come up all the time in other areas of science, and you'd make a tremendous blunder if you were just going to go ahead and try to forge ahead and come up with a number because you think probability is subjective. Okay, so let's get rid of all that. And again, if I change the evidence on the right-hand side, I can do all that because that's subjective. But then that's not subjective probability, that's just changing the evidence. The probability itself, once I change the evidence, is fixed, depending on what the evidence and the propositions are. Okay, so some of the people got the idea that probability was subjective because of Di Finetti and some others, and the idea of a Dutch book. So suppose there's some event X, and you subjectively say it has a 70% chance of coming true, whatever this event is, rain or something like this, and I'm going to pause for a moment. My neighbor is here. All right, welcome back here. Brief interruption there. Let's continue this discussion of Dutch book. So you have some event out in the world, whatever it's going to be, and it's going to be X. It could be the Tigers win, it could be anything, rain tomorrow, whatever you like. And you say it has a 70% subjective probability of occurring. But you're not thinking about it too clearly, and so you say the probability that it won't happen subjectively is 50%. Now, these two probabilities should add to 1. They don't add to 1. So that if you were to bet on this, whichever bet that you take, and I'm not going to go through the math of it here, it's real simple if you don't already see it, you stand to make a loss of 20 cents. Either because of a bet with nature, I guess you could even say just a bet with nature, or if it was a dollar bet or a utility bet, if it's not money, whatever you like. But you will face a sure loss because your probabilities are called incoherent. They don't add up to 1. And so somebody who does want to bet with you, if you're really taking these positions, they can make a sure victory of 20 cents, regardless what happens, if it's a dollar bet. And I have all the math of that inside the written lecture. You could look at it, but it should be obvious enough. If you're willing to go all the way this way and all the way this way, they should meld together. They should be coherent. And so the idea became, because you can make mistakes in betting like this, that probability should subjectively be coherent. But this is backwards. Betting is not probability. We've talked about this before, and we're going to talk about it many times when we get to decision analysis. But probability is not betting. Probability and bets are different. Bets are decisions. Decisions are not probabilities. They use probabilities, or they could use probabilities, but it doesn't mean they are probabilities. It gets things backwards, and it gets them backwards here with a Dutch book too. There's nothing wrong with this reasoning about avoiding a Dutch book, but that doesn't make probability subjective. A probability cannot be had with reference to a bet. Sometimes it might be able to, but it can't be all the time. And I'm going to prove that to you with a very simple example. I guess I have enough board space right here. So I suppose I got 100 Martians and only one wears a hat. And George is a Martian. Martian. Now, what's the probability that George wears a hat? Subjective probability, a probabilist can say any number in 0, 1. A logical probabilist has to say 0.01 or 1%, whichever you like. The person who gets their subjective probability via bets can't win, can't do anything. There are no Martians. There's no way to ever verify these bets. Coherent, incoherent probabilities mean, coherent, incoherent bets and probabilities mean nothing here, because there'll be no way to ever bet against or for nature or with anybody, because there'll be no way to ever verify this kind of a thing. So that doesn't make any sense. So whereas thinking a problem through, thinking about all the evidence that goes into probability A, B, and really thinking hard about B, and thinking about what happens if A happens, what's going on with B really there, what happens if A is false, what can prove A false, and thinking about all that stuff, that's great, that's fantastic. And if it helps you, it facilitates that thinking, if you could put it in terms of money, if that's the way you like to think, then that's fine too. There's nothing wrong with that. But once you have these things specified, this entire creature is itself objective. It is not itself subjective. I don't know how many ways to put it. I'm going to give you the written lecture too from out of the book and so forth. It doesn't seem perhaps at this point like it's a very big deal. But it is a big deal, because in the end, we are going to be thinking very hard about this B, very hard indeed in science, because we have some observable in the world, and we want to say what's causing A, and what are the conditions under which that cause operates, what are the conditions under which that cause is mitigated or blocked. So we have to think really hard about B, where the causes and the conditions are. And what it means to A. So if we just put our subjective feelings into this, then we can put anything we like. And because probability is subjective, you cannot be proven wrong. And that, unfortunately, is the way a lot of science is going. All right, that's it for now. The written lecture and everything else are in the notes down below. And next time, can't remember. Aha. Yes, we'll begin. I don't know if we'll finish. Probability is not relative frequency. Probability is absolutely not relative frequency, and I'll prove that to you. That's it for now. Thanks for listening.